The population is a collection of items for which we want to estimate some characteristic. A population can be very big or very small. The population can be anything we want it to be. For example, everyone in the United States 18 years old and less, left-handed people in a diner at 8 o'clock p.m., all the students in a particular kindergarten in a particular town, just about anything. The generic name for the number of elements in a population is capital N. We may not know the size of the population. If the population is huge, we may not be able to accurately determine N. But big or small, the size is called N, whether we can put a number on it or not. Populations have to be defined very specifically. We have to know immediately if an individual is a part of the population. We can't have a population element that we aren't really sure is in the population. A population may seem easy to define, such as all the patients in a hospital at 9 o'clock a.m. on Thursday. But even here we can have problems. Do we include the number of people in the waiting rooms? They are in the hospital but aren't yet patients. What if someone dies at exactly 9 o'clock? What should be an easy population definition suddenly becomes complicated. If a grocery store wants to survey shoppers, it has to decide exactly what makes someone a shopper. In one instance, the definition was anyone who walked into the store. Unfortunately, this included small children accompanying a parent and excluded anyone in a wheelchair. But who's to say the children aren't the ones choosing breakfast cereal? And what about the person wheeling through the store? The U.S. Census faces the population problem every 10 years. They intend to count everyone in the United States. Did they miss homeless people in a city? Did they double count anyone? Look up articles about the census potential undercounts and possible misrepresentation. The Census Bureau actually does a better job than anyone should expect. A sample is a subset of the population which is intended to represent the population. The sample size is called little n. We generally want the sample to be as large as possible, but small enough that we can collect and analyze information to estimate population characteristics. Too small a sample may not represent the population. Too large a sample costs more to collect and analyze and be more than needed to represent the population. Choosing sample size is difficult. Cost and accuracy are definitely at odds. Cost generally controls sample size selection. We may not know the sample size until after the sample is collected. Sampling fish is a good example. We take what comes, or the sample size is chosen in advance. For a sample of heart attack victims, we can choose the size. An individual piece of the population or sample is called an element or unit. For the population of all the fish in the ocean, an individual fish is a population element or unit. For patients in a hospital, an individual patient is an element. If that fish or patient is selected for a sample, it becomes a sample element or unit. Parameters and statistics go with populations and sample size. The distinction is easy. A number representing a population is called a parameter. A number representing a sample is called a statistic. Statistics are estimates of parameters, like the sample mean is an estimate of the population mean. The important part is that we can never know the real values of any parameters. That's why we estimate parameter values using statistics. Since we don't know how close the estimate is to the real value, we have to make a bet. Statistics is the bets we make on the population parameters.